open source software department at Eurogiciel, which is located in Brittany, in France. Actually, we are working on with Intel. We are contractor for Intel. I've been working on the Tizen project for 15 months now. I will show you how we can rebuild Tizen from scratch, and especially Tizen IVI. I think the presentation isn't in the right order. I mean, Dominic just before me presented the new features in Tizen 3, and on IVI platforms, we will surely have to rebuild and customize the distribution. We talk about GPS applications or anything that is needed in an IVI environment. I want to make the introduction to Tizen because I think most of the people here attended the previous session. So the most important part I would like to stress on is that each profile has to do its own enhancements. So it's very important to be able to rebuild from the sources and be able to batch, be able to add applications, core applications. And for that, we should just note that the packaging format in Tizen is RPM. So the first part is how we get from the source code to the final target device. I tried to make a small story. It's a kind of a line of C code. We could talk about that. Oops. Once upon a time, there were some developers, and there was some source code. I'm describing the tizen.org workflow because you must understand how it works right now to be able to customize the way it will be built in a private project. So on tizen.org, you have Git repositories. You have a lot of developers. Usually they clone the source repositories and they just work on the project. So they patch the source code. And the first step, very interesting, is that at this step they are able to rebuild their local package without anything. They just need a tool called GBS, and they, of course, they need the Tizen repositories located upstream. GBS is a kind of it's a Git build system. It's based on Git build package. Roughly, it takes some sources and try to pull all the dependencies, the build dependencies from an RPM repository, and then assemble, run the spec file. Then our little developers have a brand new package, you see in yellow. This package, they should. It's a very good idea to test it. And if it's not good, then you're back on your code, fix the problems, and do it again. If it's okay, the developers can push their patch for review. In tizen.org, the system which is used is Gerrit. On the next slide. So that's, this is quite related to what Dominic said before about the pyramid, where you have developers, reviewers, integrators, maintainers, etc. We have some other people that are the reviewers. They will see the patches coming from the developers, and depending on the quality of the code, they will reject the code or just comment the code and say, well, you shouldn't put this code here because it will break something or etc. Okay. If the code is good enough, they will probably decide to merge it into the Git repository. Quite on the same step, I mean, I couldn't represent the whole chronology because it's not so easy. But at the same step, the maintainers will also send a request to release manager that manage the build system, and a request, oh, this package has changed, so please rebuild it on the upstream system. So on the patch, the whole build system is based on OBS. The OBS is a system that will take the whole sources from different repositories and just build the whole packages and respecting the dependencies you will have on each package. The release managers will accept the build requests, and finally, the Open Build system will publish the binary packages on the RPM repository. The next step, we must create now binary images. So there is another tool for that, which is called Mic. It's coming from Migo and has been updated for Tizen. Migo is able to take binary RPMs and create some kind of raw images or live USB images. And so I represented two kinds of images. In fact, you have the upstream images you can find on tizen.org, the snapshot images on the upper right. But for your own needs, perhaps you need to create different images with fewer packages or more packages, or I don't know. So you can, at this step, right now, take the upstream RPMs and add your own RPMs to create some custom images. We do that regularly in France, in Van, because we had to test some components in Tizen, and we had to add tools for QA tasks. The next step is, of course, pushing the images on the devices. This can be done manually or automatically. We'll see that later. Then, of course, at the end, we have some QA team that will make some tests, a manual test or automated test, then push some reports. Of course, they will note some bugs and put the bugs on the bug tracker. And given the reports, if they think that the snapshot is quite good, perhaps it will be released as a daily snapshot, a weekly snapshot, a milestone release. Okay. So the next part is how do you customize? There are a lot of reasons for that. I won't talk about business problematics. Just on the software side, the main idea is that the vendor has to keep control on everything from end to end. So we can suppose that some sources are private. We can think that the hardware can be custom and private too. The middleware can be private. Some extra APIs are private, and custom applications, and custom release and custom upgrades. Sorry. The Tizen architecture, I won't say again what has been done, but I wanted just to note that the purple zones you can see here as some kind of some components where you can act, you can modify, and you can customize things. I mean, Tizen was done for this, because in other profiles, like mobile or perhaps in TV or I don't know, everything should be customized, and every profile will have specific things. So this is roughly where it should be done. But in IVI, probably we'll have to customize more. So how we can customize? The idea is to take tizen.org as it is and trying to follow all the release and trying to keep in sync with tizen.org, with the upstream project. And adding some private components, big components, applications. I mean, it's not inclusive. You can take either of these blocks. You could add just some applications or just some middleware, or I don't know. And the idea is to merge those two blocks and get something that is really a custom profile. I try to give a proposal for how to do that. The idea would be to get the upstream Git, the tizen.org, as a base, so you could clone that and put that in your private Git. In that private Git, you always have your developers that will get the packages, patch them, etc., push for review, have a cycle, an internal cycle. Also, you have some sources here that you will build on your OBS. You will publish internally the RPMs. You will push the RPMs, you will build images and push the images on your target devices so that your QA team is able to make tests and make reports, etc., etc. The main idea in the customization is that we have some stability because we want to have a product at the end, but we can't do that without moving because we are based on the open source products that always move. So the idea is to get some stability and just try to follow the movement. How do you do that? You do that because you try to do that by keeping in sync with the upstream projects and trying to rebase as soon as possible. You run your private build infrastructure to build regularly. As soon as there is something that changes, there is a build that is accepted. Some packages are rebuilt. A repository is published. New images are created. New devices are flashed, and new QA teams or QA teams can do that job on the new images. So it's fast development cycles. You build, you run, you test, you fix, and again and again. On the build system, actually, a good solution is to use the OBS. I mean, to use the same system that is used on tizen.org. In the future, perhaps it will change. I don't know. Actually, it's a best solution. OBS, for those who don't know this project, it's an open and complete platform for building a whole Linux distro. It's open source is using and maintaining the build system. It provides the infrastructure to build software packages for many architectures. In tizen.org, we use essentially Intel architecture, 32 bits or 64, or ARM, and maybe next month we'll have ARM 64 bits. The builds are quite fast because the packages, the build of each package is distributed on multiple workers. It's not centralized. I mean, you have to have a server, but the workload is distributed all over multiple workers, and you can have as many workers as you want. And the builds are quite smart because the OBS system has a scheduler and a resolver that is able to detect the dependencies of the packages. And so when the package changes, only the other dependent packages are rebuilt. you won't rebuild the whole disco every day. You just rebuild what changed and the dependencies. So in a fast development cycle, as I told previously, on an everyday basis, it's very fast. You make a change, you get your snapshot, you test. You can do that maybe 3 or 4 times a day. Just if you want to have an idea of what is an OBS, an easy thing is to go on the tizen.org and just visit the OBS. It's a read-only, okay? But you can see all the projects, you access all the repositories, and you can see how it's built. Multiple architecture can be seen. And the main project, there are a lot of projects on the OBS because there are also a lot of development projects that are not official. It's just new components that must be integrated, but that are built there, but not yet integrated in mainstream. So the main projects are Tizen generic with 2 flavors, one with X and another one with Wayland. You have, of course, IBI, Tizen Mobile. To keep the link with the Git repositories, just a small note. One Git repository usually is associated to one project, one package in each OBS project. There's no much mix between. It's quite difficult to maintain if you don't follow this rule. And also, the binary repositories, I mean the RPMs, are available on download.tizen.org. The final result of the OBS. From our experience in Van, we use for more than 1 year now to ease development of major Tizen features. There was a big task consisting in importing the web runtime to 64 bits. Recently, in September, we made the first setup for Tizen generic before it was official, and we had to prepare the whole project. More recently, we will use a private OBS to make our test on multi-user mode. To make it simple, if you want to change just one package, you don't need an OBS. But if you want to develop more components that are more tricky dependencies, and if you change something, you are not sure what the impact on the other side of the project, you need an OBS because you won't be able to rely on the repositories that are on tizen.org. You must rebuild everything regularly to be sure that everything is okay. So our setup is quite simple. We are a team of 15 people. So we have 15 desktop computers. They were both in 12, so it's not big computers, as you see. On the server side, we just took the official appliance that is available on OpenSUSE, on OBS site, in fact. And we choose to use our desktops as workers. Usually, if you look at the OBS on tizen.org, you will see they have 15 or 20 machines with 8 cores each, etc., etc. But it's a big infrastructure. We didn't do the same. We didn't want to buy some computers to dedicate to the build. So we use our own computers. We had to make some specific setup to reduce contention because working on the desktop and building some packages in background is not always so easy for people, but with some configuration on control groups and memory and some temp FS, it works just for a benchmark. if you want to rebuild the Tizen profile with the computer, it will take less than 4 hours. It's not bad. I mean, even if you customize a lot your distribution, you will be able to rebuild Tizen 6 times a day. It's more than you can test. The next part is, okay, now we are able to build. So now the final part is how to flash, to run, and to test. The binary images are created automatically because we are able to put some hooks on the OBS and catch when the OBS finishes a build cycle. The build cycle is when all the dependencies, all the packages with the dependencies have been rebuilt, and there is nothing more to do. There is something the OBS will have something else to do when we push a new request. Okay? So each time the cycle finishes, there is a new snapshot that is published. The snapshot is the whole RPMs put aside. On the RPMs, we assemble automatically images, raw images, in fact. And we build also special QA images for automation. In detail, we have to log in automatically, so we don't have to put a password, and we have to put some extra tools to automate tests. So the images of it are available for everybody for automatic test or manual test. That's very important, and they are available for everyone. I mean, worldwide. If you want to publish your images every day and say that's it, the daily images, it's okay. There is no problem with that. Every developer can take the image, flash it on a device, or boot with a USB stick, and will be able to work on the latest version. Our experience on that is that we pushed a little further and wanted to automate a lot of tests, because when you change a little piece of code, everything is rebuilt, you rebuild images, and you want to know if you don't break something. And why do that manually, as it could be done automatically? So we developed a process where everything is done automatically. So we can conclude by saying we are able to go from the sources to the final test, and perhaps, let's say, 4 times a day. The same seaside. If you have questions. No?
Okay, thank you very much, Stefan.